Chapter 6, Combustion and Flame, Part 2. In Part 1, we saw the introduction, what is combustion, what is flame, and how we have to control the fire. Let's continue with this Part 2. There are substances like phosphorus, which burn in air at room temperature. Regarding phosphorus, we also discussed in the lower classes. As you know that phosphorus we have to keep in the kerosene. That's why it is normally keep away with the air, because if it is directly contact in the air in the room temperature, it gets the burn and the fire will be spread. The type of combustion in which a material suddenly bursts into flames without the applications of any apparent cause is called the spontaneous combustion. So one of the example of the spontaneous combustion is the phosphorus, because it will automatically when it will comes into the air, in the contact with the air, it will automatically catch the fire. That is called spontaneous combustion. That is in the room temperature. Now we'll see the types of the combustion. Bring a burning matchsticks or a gas lighter near a gas stove in the kitchen. As you know that in the gas, what will happen? The fuel gas is basically come out of the burner. So when we bring the matchsticks or the lighter, it will automatically catch the fire. So we find that the gas burner rapidly and produce heat and light. So it will fire it. This type of combustion is known as the rapid combustion. That means some fuel is basically come out, and if some heat material is going near to be it, so it will catch the fire. This is called rapid combustion. You know the flame. This is the very familiar word with you. There are different kind of the flames you can see. Here you can see like a candle. You can see the difference between candle flame and the gas stove flame. Both are the different in the color. That different of the temperature also. Colors of the candle and the flame of a kitchen stove. So you can observe the LPG flame. Can you tell the color of the flame? Yes. What is the color of the candle flame? It is less like a little bit yellow. And in the stove, you can see there are some little bit bluish color. Clear? As you can see in the diagram, you can do the experiment also in your home. But you have to be very much careful. Structure of the flame. So now there is one question. The flame is flame. What is the structure of that? But there are different kind of the layers of the flame also that we'll see in this diagram. As you can see, here we'll understand with the help of the activity. Light a candle, be careful. Hold a glass tube with a pair of the tongs and introduce in some end in the dark zone of a non-flickering candle flame. Non-flickering candle flame, that means it should not be white. Clear? It should not be moved. It is the steady. Bring a lighted matchstick near the other end of the glass tube. Do you see the flame? Of course, you can see. That means some heat is basically come out into the glass tube, and the matchsticks of the opposite side, it will automatically get the lighted. So this is one experiment over there. The structure of a flame like this, you can see. So if so, what is that produce a flame? Notice that the wax near the heat wick melt quickly. That means you can see in this diagram, the wax is basically melt very quickly, because the temperature or the heat is very much more than the some other areas of this flame. So the substance which vaporizes during the burning gives flame. For example, kerosene oil and molten wax rise through the wick and are vaporized during the burning and form flames. Charcoal, on the other hand, does not vaporize and so does not produce a flame. That means from the charcoal, we cannot see the different flames, but only the smoke, that is carbon dioxide. As you can see over here, when a candle is there and we just use a normal glass, what will happen? The carbon will basically gather near the glass, and you can see after some time, some black material you can see over here. So this is the burning flame. It converted into the carbon dioxide and stick into some other area. Even in your home also you might have seen in the kitchen, some of the roof are basically a little bit darker, that is in black color. So why does it happen? Because the flames, it normally produce some kind of the smoke that is in carbon dioxide. If it is the lighter, that it will goes up and some black colors, carbon dioxide or black colors, some particles of the carbon dioxide will gather over that. So when the candle flame is steady, introduce a clean glass plate light into the luminous zone of the flame, as you can see in this diagram. Hold it there with a pair of the tongs for for about 10 seconds. Then remove it. What will happen? So what do you observe? As I told you just now, that you can see the some black color spot will be there on the glass tube or the plate. Okay. Here we'll see different zones of a candle flame. As I told you earlier that. So what are the part and how the flames or the heat of the different kind of the flames you can see over here. So as you see, we'll start with the wax candle, as you can see over here in this diagram. So this is one lead, that is innermost zone of the unburned wax, that is vaporous black. This is the black is basically come out from this area. Clear? Then here the nearby the area of the hot wax lead, that is the least hot. That means that it is not that much of hot. Little bit will go up middle of the zone of the partial combustion, that is in yellow. Then little bit upside, that is it is converted into the little bit orange color, that is moderately hot. And here of the hottest part, the outer side of that, you can see that is normally blue color, that is the hottest part, and outer zone of the complete combustion, that is in the blue color. So normally we can see the flame outside of the flame, it is very much hot in comparison of the inside. This is the basically structure of the candle flame. The same structure we can see in the different areas of the different fires also. Yeah, that is a good question. What is fuel? You might have, and you are familiar with that. Petrol, kerosene, diesel, CNG, LPG, these are all fuels and which we can use for the in our day-to-day life. So the source of the heat energy for domestic and industrial purpose are mainly wood, charcoal, petrol, kerosene, etc. These substances are called fuels. There is probably no fuel that could be considered as an ideal fuel. Why does it not call the ideal fuel? Because all the fuels are basically catch the fires very easily. That's why. Fuel efficiency. The amount of heat energy produced on complete combustion of 1 kilogram of the fuel is called as calorific value. So what is calorific value? So the complete combustion of 1 kilogram of the fuel, we can take any fuel. So it is called calorific value of this particular substance. So the calorific value of a fuel is expressed in a unit called kilojoule per kg. That is kJ per kg. This is the unit that you have to remember. And calorific value of some fuels are given in the table. That means how much fuel if we can burn, so how much energy can we get it. For example, cow dung cake. From 1 kilogram of the cow dung cake, we can get 6,000 to 8,000 kilogram heat energy. From the wood, we can get 17,000 to 22,000 kilogram, 22,000 heat energy. Petrol, we can get 45,000 energy. Kerosene, we can get also 45,000. Diesel also 45,000. Methane is also important gas, but which we are not using in our day-to-day life, which we can get from the earth. That is also 50,000. CNG, that is calorific value is 55,000 kilojoule per kilogram. Biogas, that is with the help of the cow dung, we can use it, that is 35,000 to 40,000. And last is hydrogen gas. Hydrogen gas is takes around about 1,50,000. So these are all the different values of the calorific values of the 1 kilogram of that particular fuel, and the calorific value we can get it in the kilogram per kg. Burning of fuels leads to harmful product. The increasing fuel, that is consumption, has harmful effect on the environment. As you know that nowadays there are different kind of the vehicles are there, like CNG vehicles, petrol vehicles, electronic vehicles, then diesel vehicles, all produce some heat energy. Along with the heat energy, it also produce some carbon dioxide, which can directly affect to our environment, and it will increase the pollution along with the sound pollution, noise pollution, and the environment, that is air pollution. So, one, carbon fuels like wood, coal, petroleum release unburned carbon particles. These fine particles are dangerous pollutant that causing the respiratory disease such as asthma. That means in the metro cities, if you're going there, so in your inhale, instead of oxygen, we are getting more carbon dioxide. So it will do the problem for the human life, and that is called the asthma. The person who has problem with the taking the air, that is called asthma. Second, incomplete combustion of this fuel gives the carbon monoxide gas. That means if the wood is not properly and the completely burn, so it can produce carbon monoxide gas. It is very poisonous gas. It is dangerous to burn coal in a closed room, and the carbon monoxide gas produced can kill the person sleeping in that room also. You might have seen, or you might have heard about that, when the fire catches in the building, some people is basically die with the carbon monoxide gas. That means they cannot breathe, they cannot take the clean air instead of carbon monoxide. They are not basically burned, but they get the carbon monoxide and die in the sleep also. First of all, the person will faint and then it will die. Third, combustion of the most fuel release carbon dioxide in the environment, as I told you earlier. So increase the concentration of carbon dioxide in the air is believed to cause the global warming. So as you know that there are more vehicles, so more carbon dioxide will be produced, and it will increase the temperature of the globe, that is our world, and it is cause of the global warming. And the last point, 4, burning of the coal and diesel release the sulfur dioxide gas. It is an extremely suffocating and corrosive gas. Moreover, petrol engine gives off the gaseous oxide of the nitrogen. Oxide of the sulfur and nitrogen dissolve in rainwater and forms the acid, that is called acid rain. So such rain is called the acid rain. You might have heard about this word, what is acid rain. Okay, and if you don't heard, then we can learn in the higher classes. It is very harmful for the crops, buildings, and soil. So the use of diesel and petrol as fuel is the automobiles is being replaced by the CNG. The full form of the CNG is compressed natural gas, because CNG produce the harmful products is very small amount in comparison of diesel and petrol. And nowadays you know that some electric vehicles are coming. So electric vehicles, we do not require any kind of that burning fuels like CNG or the petrol or the diesel. So it can save our energy, it can use, and it can help us to decrease the carbon dioxide from the automobiles. So CNG is the clear fuel, we can see like that. Thank you.